Hey everyone, and welcome. Today, we're going to build a bridge between two Python applications. And not just any old bridge, but a super powerful event-driven connection using one of the most important tools in modern software, Apache Kafka. Let's see how it all works. So first, let's set the scene a little bit. Modern apps are often built as a bunch of smaller, independent services. You might have one that handles user accounts, another for processing orders, a third for sending emails. But how in the world do they all coordinate? How does the orders service tell the shipping service that a new package is ready to go, especially when you might be dealing with thousands of orders every single second? Well, the answer is a really elegant pattern called event-driven architecture. Instead of one app directly calling another, which can get messy and create all sorts of dependencies, they communicate through events. And an event is just a simple record that something important happened, like, hey, an order was created, or a user just logged in. Services can just broadcast these events out into the world without even knowing, or frankly caring, who might be listening. And that is where our star player for today comes in. To manage all these events flying around, you need a central, super reliable system. You need a message broker, and honestly, one of the best in the business is Apache Kafka. The core idea behind Kafka is actually pretty simple. The best way to think about it is like a high-performance digital post office for all your applications. One app can drop off a letter, which is our event, and another app can come and pick it up from its mailbox, all without those two apps ever needing to meet or even know about each other. All right, so what do we actually need to build this? For our little project today, we only need 3 core components. It's way simpler than you might think. First up, we've got our Kafka cluster. That's the central post office itself, and we can get one running really easily using Docker. Then, of course, we need our applications, which we'll whip up using the awesome Python framework FastAPI. And finally, the secret sauce, the magic glue, the AIO Kafka library. This is what gives our Python code the superpowers to speak Kafka's language. Okay, let's get our hands dirty and dive into the code. We're going to start with the application that writes the message. In the world of Kafka, we call this a producer. A producer's job is incredibly simple. It just creates a message and sends it off to Kafka. It has no idea who's going to read it or even when they'll read it. It just needs to know where to send it. And that where is what's called a topic. A topic is just a named category or a stream for messages. You could have an orders topic for new orders, a users topic for new signups. You get the idea. It's the specific mailbox where we're sending our letters. Now let's look at the code. Using AIO Kafka, we create what's called a producer instance. The most important part here is bootstrap servers. That's just the address of our Kafka post office, the front door to the whole system. Then we just await producer.start to get the connection up and running. And sending a message? It's literally one line, send underscore and wait. We just tell it which topic to send to, in this case, orders topic, and then we give it our actual message data. That underscore and wait part is super important. It's basically our guarantee, our delivery receipt that the message made it safely to the post office. And boom, just like that, our letter is in the mail. The producer's job is totally done. It can go on with its life, completely confident that its message is safe and sound inside of Kafka. All right, so we've sent the message. Now for the fun part. Let's jump over to the other side of our system and see how a different application can pick it up. And this is the job of the consumer. The consumer's whole purpose in life is to subscribe to a topic and just wait. Whenever a producer sends a new message to that topic, the consumer will wake up, receive it, and then do something useful with it. Now, this brings us to a concept that is really, really powerful, the consumer group. Think about it. What if our receiving application gets really busy? What if we're getting slammed with orders? Well, we can just run multiple copies of it. And by putting them all in the same consumer group, Kafka is smart enough to deliver each message to only one of them. This is how you get massive scale and avoid 2 different systems accidentally processing the same order twice. The code to set up a consumer is going to look super familiar. We create an AIO Kafka consumer, we point it to the orders topic, and we give it the same bootstrap server's address. But here's the key addition. We assign it a group ID. This tells Kafka, hey, this consumer is part of the orders underscore consumer underscore group team. And the code to actually listen for messages, this part is so elegant, I love it. It's just an async for loop. Our application will basically just pause here, and as soon as a new message arrives on the topic, the loop will run, and we can grab the message and process its contents.
And there you have it. The letter has been delivered and it's been read. We have successfully communicated between two totally separate applications, and they never even had to know that the other one existed.
So we've sent a message and we've received a message. Kind of cool, right? But let's zoom out for a second and talk about why this simple producer-consumer pattern is such a game changer, why it's a cornerstone of modern software. Let's put them head to head. You've got the producer on one side, consumer on the other. You can see they both connect to the same Kafka cluster. The producer sends to a topic, the consumer listens to that topic. But look at that last row. That's the crucial difference. The producer is completely oblivious. It has no idea who's listening. The consumer, on the other hand, operates as part of a coordinated, scalable team.
This design gives us three huge benefits. First, decoupling. Your services are totally independent. You can update the shipping service without ever touching the order service. Second, scalability. If you suddenly get a flood of orders, you just launch more consumer instances in the same group. That's it. And third, resilience. This one is my favorite. If you're receiving application crashes, the messages just wait safely in Kafka until it comes back online. Without this, if your service went down for 5 minutes, every single order in that time could be lost forever. With Kafka, not a single piece of data is lost.
So the big takeaway is this. That simple act of sending and receiving a message through a broker like Kafka unlocks incredible power, flexibility, and scale. This isn't just some niche pattern. It's the backbone of everything from e-commerce sites to massive real-time data analytics platforms. The only question left really is, now that you know the pattern, what are you going to build with it?